In this video, we're going to take a look at the iForway HS1000 portable power station. The iForway HS1000 is a power station featuring lithium iron phosphate battery cells, a 1000 watt inverter, and 1228 watt hours of energy storage. The manufacturer promises very fast charging speeds, 2000 watts of surge current handling, and a UPS function for keeping critical devices on even if grid power fails. It is currently selling for $715 US on Amazon, so let's go ahead and unbox it and take a closer look. Before we unbox this, there was a little bit of confusion about this product when I first got my hands on it, so I've done my best to work with iForway to clear up all that for you. There isn't much going on inside the box, just the HS1000 itself, an AC charging cable, and a DC charging cable for use with a cigarette lighter socket. As a quick note, if you want to purchase the HS1000, be sure to use the link and code in the video description, and iForway will send you a free MC4 solar charging cable with your purchase. There's also a user manual and a warranty card. The warranty card does provide contact information, which is more than some other units I've reviewed can say, but the phone number is a Chinese phone number. That won't be much help in the US. I did get a US contact phone number from iForway that I will include in the video description for you to use if you have any problems. To comply with regulations, these units always ship mostly discharged, so the first thing we need to do is charge it up before we can begin the testing. I've been working on a standardized set of tests for these power stations. Here's what we will be testing on. The 16 items on the left are what I will be attempting to test for every portable power station that I review on this channel. A few of the categories I'm still working on getting test equipment for, but we'll do our best. In the second column, these are iForway's ratings for the HS1000. A few of these are ambiguous, as I mentioned before, such as the AC charging. Some documentation says 600 watts and some says 1000 watts. I was told that the varying numbers are due to the different models for different countries that use different voltages and frequencies for AC power. So some countries can charge faster than others, but I'll find out what the real number is for the United States market, and the results of each test will be marked in the third column. The fourth column is for notes, such as you can see that I noted that iForway doesn't specifically claim that the HS1000 can do pass-through charging or dual charging, but we're going to test to see if it works anyway. With it fully charged up, we'll start with the low power test. For this test, I use a load that's around 30% of the rated AC output power of the inverter. In this case, the inverter is rated for 1000 watts continuous, so something around 300 watts will be good. A single 250 watt heat lamp only pulls 230 watts from the HS1000 because it isn't producing a full 120 volts of alternating current. So I added in a 100 watt incandescent bulb to give us a 320 watt load. The low power test finished after 221 minutes, which is pretty close to the expected runtime, so we'll give that test a passing grade. After recharging the HS1000 again, we'll move to the high power test. For this test, I used a load that's around 90% of the rated AC output, so we want about 900 watts. 4 of the 250 watt heat lamps did the trick to give us 915 watts of load. The high power test finished after only 64 minutes, which is off the expected runtime. I'm sure it was struggling with heat as there were 4 heat lamps shining nearby, plus a 100-degree ambient temperature, and a high load on the batteries. Still, we have to give this test a failing grade. While we have the HS1000 fully discharged, let's test the AC charging capability. With it inside and cooled down after the high power test, I plugged in the AC charging cable through my power meter to verify the incoming power. So we'll let it run and see how long it takes to fully charge. The charging test completed after 117 minutes at 775 watts or so. So it passes the test, but the documentation showing a 1.5 hour charge time at 1000 watts is clearly inaccurate for the US market. Now for the torture test. Let's see if the HS1000 can go over its 1000 watt continuous rating for 10 seconds. For this test, I want to load it up about 10 to 20% over its capacity, which would be a target of 1100 to 1200 watts. I played around with various loads until I could reliably hit in that range. This test passed with flying colors. I let it run for well over 10 seconds and it didn't complain at all. I'm skipping the air conditioner test because a window air conditioner will draw too much power for this size of inverter. But let's go ahead and test a large dorm refrigerator. As expected, it handled it just fine. So here's a look at our scorecard now. So far the HS1000 is doing really well. Next, let's check the AC output voltage and frequency. Using my AC power meter, I measured an even 60 Hz and 112 volts. 112 volts is acceptable for the US market, although it is a little bit low. And like we saw with the heat lamps, you may not get full power out of some resistive loads. But it is a passing grade. If you buy the HS1000 with the link in the video description and use the code, you won't have any problems with solar. But if you didn't, you will most likely need to buy an adapter that converts the industry standard MC4 connectors to the Anderson power pole style connector that iForway uses on the HS1000. Most people use foldable solar panels with power stations, so I grabbed one for a demonstration. But it's only 100 watts, unfortunately, so I won't be able to solve the mystery of whether the HS1000 can input 200 watts or 300 watts on the solar input. But it did perform well and was able to convert 80 watts into usable power, which is about the best that you'll ever get in the real world with any solar panel and any charger. So that test is a pass. While we're at it, let's see if it can do dual charging. So I plugged in the AC charger and we were able to get both solar and AC charging to work at the same time for a total of about 840 watts. So 2 more tests are a pass as the MPPT solar input works well and it can dual charge from solar and AC power at the same time. Unfortunately, I don't have my DC capacity test rig built yet. I tried running this DC powered fan for 2 days straight to test the full capacity of the HS1000, but the fan kept shutting itself off, and I don't have 2 days to sit around waiting for a single test anyway. So I won't be testing the DC performance on this unit, but I can test the pass-through charging and UPS capabilities. Pass-through charging means that a device can charge and discharge at the same time. The AC power passes straight through the power station to the load, and the power station also pulls power to charge itself. That clearly works great on the HS1000. Now, if I pull the AC charging cable, if the UPS function works like it should, the computer should still stay running. And it does. The UPS function passes its test too. So we have another pass test on the UPS function. Unfortunately, as I mentioned, I can't adequately test the DC output at this time, and I don't have an oscilloscope yet to test the waveform. So the only one left that I can properly grade is the capacity or energy storage. In the low power test, the HS1000 delivered 1,178 watt hours, but in the high power test it only delivered 976. That's an average of 1,077 watt hours. So I'm going to give it a pass and a fail on this one. I think the battery bank inside is properly rated, but it may struggle to cool itself at high loads, and thus you may not be able to get the full capacity at its limits. In conclusion, the iForway HS1000 performs well and does pretty much everything they say it can do. The company responded to my criticism and offered a US-based support phone number and a free MC4 adapter cable to my viewers who might want to buy it. Thanks for watching this video. If you found it helpful or entertaining, please leave a thumbs up and comment below.